looking at number 2, limit definition. Limit as h approaches 0. Again, of f of x plus h minus f of x all over h. All right, so we have the f of x plus we need the f of x plus h, which is what we would get if we replaced the x in the original function with an x plus h. All right, so that's something, or at least a step that we should be getting more and more comfortable with. All right, so cosine x plus h goes in for f of x plus h, giving us limit as h approaches 0 of cosine x plus h minus cosine of x all over h cool. So what I need to do is expand this out, because we're looking at something that's not really too friendly in terms of being able to be simplified. All right, so I have the cosine x plus h. That's the big one there. If we remember our sum and difference identities, then we're in a good spot. If not, it's at the top of the page. I'm just going to rewrite it here, though, just so I don't have to scroll back and forth. It's tough enough to see the board as it is. So cosine a plus or minus b is equal to cosine a cosine b, poor quality b, minus plus sine a sine b. And all that really means is that the plus sign in the simplified form corresponds to the minus sign in the expansion, all right, and vice versa. All right, so using that, I can expand out cosine x plus h, which would be cosine x cosine h minus sine x sine h. So that whole shabiggity bangity boomity boom, shakalaka, is equal to cosine x plus h. So I'll make that substitution. These trig problems, they get uglier before they get nicer. I mean, it's not really an antonym relationship, but whatever. All right, so cosine x cosine h minus sine x sine h minus the cosine x that was already there all over h. Oh, I went a little off the rails there. So I want to be able to simplify this. Yeah.
Is there any, like, after you write, just to move it to the top of the screen? Because it's always very hard for us to write.
Oh, yeah. I was trying to, like, balance it with having some of the solution visible.
Yeah, I'm
but
sorry. There's just, like, so many heads in my way. I can't see.
You heads know who you are.
Thank you.
You have been warned. Do not come into class again with those heads. So, cosine x can be simplified out of this whole thing, but after we make some maneuvers here. All right. So I'm going to change it up to red. See these two terms here, this one and this one, each have a cosine. So I can group those together and make a single fraction out of those two terms. All right, that's going to allow me to factor out a cosine of x. All right, so I'm going to show the intermediate step. Limit h approaches 0, cosine x, cosine h, minus cosine x, all over h, that would be one fraction, minus sine x sine h, all over h. That would be my second fraction. Now if we go the other way and try to put this together, it would all work out because we have a common denominator. Question?
Before it said like cosine a plus b, but then there was like subtraction in the middle of it. I was just kind of confused where that like came from. But yeah, like there were the two different signs.
Yeah, so this is the general rule that applies in all cases. We're only focusing on the sum rule for cosine because the x plus h has a plus in it, and that corresponds with the minus. So this plus corresponds with the minus in the rule in the expansion. If we had to subtract, get a green here. If we had cosine of, let's say, x minus h, then we would expand it using a plus sign. It's just a matter of how the rule just works itself out.
Does it matter if the minus is on top? Because like in the front it has the plus over the minus, and then the second one is minus over plus. Does it matter?
Yeah, because the plus in the first one corresponds with the minus in the second one,
Oh.
and the minus corresponds with the plus.
Okay.
All right. Bless you. So I have my common factor here of cosine x. You can pull that out. All right. So this would be cosine x times cosine h minus 1 over h. The other fraction, I could just kind of split the fraction a little bit and just write it as sine of x times sine h over h. Still limit as h approaches 0. But it's the limit as h approaches 0 of this entire expression. And what we've been talking about, for a couple of units now, is the idea that if you're taking the limit and it involves a plus or a minus, you can find the limit of each piece separately. All right. So what I would do is find the limit as h approaches 0 of this piece. And the limit as h approaches 0 of this piece. I'll scroll it up in a sec. All right, now we can factor out the cosine x from the first limit, and we can factor out the sine of x from the second limit. And the reason we could do that is because neither of those factors have an h in it. They don't need to be part of the limit where h is approaching 0. So we're talking cosine of x times the limit as h approaches 0 of cosine h minus 1 over h minus sine of x times the limit as h approaches 0 of sine h over h. And each one of these pieces amounts to a rule. All right, top of the page, you can see what those are. But short answer is this one goes to 0. This one goes to 1. And so after all of this, we have cosine times 0 minus sine times 1, which is going to be negative sine of x. And so that's what my derivative is going to be. Sorry. F of x. All right. So f prime of x. So now we just got to do that again, but in an instance where the coefficient is not equal to 1. And then we're going to discover some rules. Because what's happened here is we just learned that the derivative of sine is equal to cosine.
Mr. King?
Yeah.
Like, what happened to the cosine x of the problem above?
Cosine x times 0.
Oh.
Yeah. So we learned that the derivative of sine is cosine. We also learned just now that the derivative of cosine is equal to negative sine. And we want to see if we can expand on that. All right, so for number 3, now we have a coefficient of 2, but it's still going to be doable. We just have, there's an extra step in the early going that we'll have to account for. All right, so still limit as h approaches 0, f of x plus h minus f of x all over h, at least until we discover some shortcuts along the way. All right, so f of x is equal to sine of 2x. F of x plus h would be equal to sine of 2 times, instead of x, x plus h. Now we can actually expand that before we even get into a rule. Just by simple distributive property, nothing too crazy. So sine two x plus 2h is what f of x plus h would amount to. So I could put that into my limit, but we're still going to have to expand that out. But I'll write it in first, and then we'll do the expansion. So sine of 2x plus 2h minus sine of 2x all over h. And we talked about this yesterday. This is a sine function, but it is a sum. Sine of the sum of two angles. So it's a sum rule for sine. All right, so sine of a plus b, a plus or minus b really, is equal to sine of a cosine of b, poor quality b, plus or minus cosine of a sine of b. I wrote it a little differently on the previous page, but it amounts to the same thing. I just kind of prefer it this way. All right, same structure, except the signs sort of kind of played different roles here. All right, so it's expanded into the product of two terms that are added to the product of two other terms, and but there isn't a reversion of the signs. All right, so plus stays plus, minus stays minus. All right, that's why it isn't plus minus followed by minus plus. All right. So what we want to do is expand sine of 2x plus 2h using this identity. Yep. So all of that, just like the previous one, all of that is what the sine of 2x plus 2h is going to amount to.
Just for chaos, why
Yeah.
is it plus in the middle if the beginning equation is negative?
You talk about here?
Yeah.
Because we're only working with this part, and that part has a plus sign in it. So limit as h approaches 0 of all of this stuff minus my original sine function, sine of 2x. Just reorganizing a little bit. All over h. We're going to do the same thing we did previously. Split up the fraction, group common factors together. So you see here I have a term that involves a sine of 2x. And I have another term that involves a sine of 2x. So I want to make a single fraction out of those. So I'd be looking at sine 2x cosine 2h minus sine 2h over h plus cosine 2x sine 2h also over h with the limit out in front. We can split the limit and also factor out the sine of 2x and the cosine of 2x all in one shot. I think that's probably an efficient approach. So we would say the limit as h approaches 0. Well, I didn't even factor it out, so I might want to do that. So we would be pulling out the sine of 2x from the entire limit. So it would give us sine of 2x times the limit as h approaches 0 of cosine 2h minus 1 over h. That would address the first fraction. Then for the second one, that's where that sine of 2x would come from. It just factored out of the whole thing. For the second one, I'd remove the cosine of 2x so cosine 2x times the limit as h approaches 0 of sine 2h over h. Both of which are almost a rule, a shortcut rule for limits, but not quite. We're almost there. The problem is, if you want to apply the shortcut rules for canceling out these trig limits, whatever the argument is of the trig function needs to be the same as whatever's on the bottom, but in both cases. So in order to make that happen, I'd have to multiply the top and bottom of each of these fractions by 2. I'm going to shrink this down and zoom in a little bit more to create a little bit more room. Alright, so to rewrite, I'd make this sine of 2x, but that 2 on the top, I can put that wherever I want. This one, let me get a different color involved. Go to the red. This 2, I could put it wherever I want, because that's not the reason why I multiply the fraction by 2. I multiply the fraction by 2 so I can make the bottom into a 2h. So that top 2 can be factored out of the whole thing. So I'm actually going to put that right on the outside. And that would give me the limit as h approaches 0 of cosine 2h minus 1 over 2h, which now actually gives us the rule that we're looking for, because those two arguments agree with one another. The expression that's contained within the cosine function matches what's on the bottom of the fraction. All right, which is ultimately what we want. And the same thing would be true for the second fraction. That 2 on the top, I don't care where I put that, so why not just take it out of the whole thing and make this plus 2 cosine 2x. And that allows the limit to contain a sine of 2h over 2h, which again makes it the rule that we're looking for, because the expression contained within the trig function matches the expression on the bottom of the fraction. We're allowed to take that first limit and cancel out to 0. The second limit we can cancel out to 1. So all of this is going to go away because anything times 0 is going to become 0. So this entire expression collapses down to just a 2 cosine 2x. And so that's what my f prime of x would be. All right. Now there's a shortcut in there. Maybe you figured it out already, maybe not. But what I want you to do is try number 4 using this approach. A similar approach. You'll have to do it more like number 2 on the previous page. But then there's a table at the bottom, and you can see in that table different coefficients for sines and cosines. You should not have to reinvent this process. After you do number 4, you should kind of get an idea of what the shortcut is and not have to use a limit approach anymore. That's the whole idea. All right, so take the remainder of class and give that a shot.